terms of your leadership with Intel as a technology supplier, when you were with Intel, a lot of the panelists up here have spoken this week about the effect that mobile and all these applications are driving into the data center. There's a lot of workload being driven into the data center by all these devices we carry around with us all day. Can you describe from the semiconductor industry perspective the response in terms of the technology to the products that Intel and other customers are creating to react to that demand, that increased workload demand in the data center?
I think that goes to Moore's law, and okay, this slide is up here. This is a slide showing Moore's law. My career in the semiconductor industry started in about 1973 and ended in about 2005. So I followed this curve down or up, whichever way you want to look at it. On the left side, you go from the number of transistors goes up quite dramatically, and the cost per transistor goes down dramatically. The number of transistors basically doubles every 2 years. So that has implications on everything. I have a cell phone on that's probably more powerful now than my first computer. In fact, the hearing aids that I've got are probably more powerful than my first computer. They're all digital, so, and they're Bluetooth enabled, so I'm pretty well wired. But this trend, building factories to produce the chips that went through this time period was quite an amazing deal. The first factory I worked in was a very small factory in Hillsboro, actually in Aloha, Oregon, and it would now fit in one corner of one of the big mega factories that we built. So it's transitioned through time, and the capabilities are quite impressive. One slide that impressed me the most is if you look at Moore's law and what it's done on microprocessors, there was another thing that went on is that every time you added transistors, the power load on the chips went up. But it did flatten out in the early 2000s, and pretty much the typical microprocessor is in the 100 watts range. Some of them are as high as 130 watts. But it flattened out, and you can see the impact that it's going to have on servers. I'm not an expert in building data centers. My expertise was building fabs, but this would have implications on your data centers. We built a high-density data center, but it tells me that at some point you're going to see a flat line on how much heat load you can put into a data center. You can only dense pack servers so tight. You can only dense pack the racks so tight, and it's going to be getting the airflow in and out. But if you look at that Moore's law, it's going to continue. A lot of people predict that it's going to end, and everybody I've seen predict it, including a couple of my former bosses, were always wrong. They predicted the end in the 1990s, and it's still going on, and I think it'll go on for a lot longer. But what's going to happen in a data center is that every couple of years, the capability of that data center has the potential to double. The heat load's probably going to flatline at some point, but the data center is going to double. So if you have a facility that's built to last 10 to 15 years, the technology that's being loaded into it is obsolete in 3 to 5 years. So you're going to go through maybe seven technology changes through the life of that building, and the output over a 14-year period is going to be something like 64x. So that's quite an intense amount of new data coming into that basic footprint that you're putting there. So my learning from building semiconductor factories, the most important thing you can do is make sure that you've got your utilities calculated correctly and the infrastructure put in place, because trying to go back and retransfer all the data you're going to be bringing into the facility or the power loads, you can't do it, and you can end up impairing that facility long before the lifetime should end if you don't anticipate those loads adequately up front.